In this video, we are going to cover classes and object-oriented programming in Python. Specifically, we're going to cover Chapter 9 of the book Python Crash Course. We'll start out by learning how to create a class, how to create an instance of a class, and also how to deal with inheritance. If you want to follow along, feel free to subscribe to the channel. Let's get right into it. Object-oriented programming is one of the most effective approaches to writing software. So far we have written smaller snippets of code, but especially as we are writing larger applications, it becomes really important that we structure our code in a better way, and object-oriented programming can really help us do that. So in object-oriented programming, we are going to write different classes that represent real-world things and situations, and then based on those classes we can create objects. So when we write a class, we define a general behavior that a whole category of objects can have. Creating an object from a class is called instantiation, and we're going to work with instances of a class, which are called objects. We can model almost anything using classes, and let's start out by writing a simple class, a dog class, that represents a dog. Not one dog in particular, but basically any dog. And our dog is going to have a name and an age, and in addition to that, our dog should be able to sit and roll over. So these are the actions our dog can take. So let's get started and let's actually take a look at how we can do that. We switch over to our text editor. Initially we can use the class keyword followed by the name of the class, which is capitalized, so dog in this case, to create our dog class. That's followed by a colon, and after that we have our dog string here, which simply states what our class is about. Now, the first aspect here that we need to add to our class is the init method, which always starts with 2 underscores, the keyword init, and 2 underscores after that. And after that we have parentheses, and inside of those parentheses we'll find the parameters that we're using with our init method. And this init method is called automatically when we later on create an object from our class, so when we instantiate our class. Our init method here takes 3 different arguments: self, name, and age. And what we're going to see is with all the methods we are working with that we always pass the keyword self to it, which refers to the class itself. And important to mention, we're using the word method instead of function. So a method is basically a function that's associated with a class. Inside of our init method we have again a dog string that briefly describes what this init method is actually about, and then we are using this syntax here to actually initialize the different variables that we're going to use. We're using self, which means we are referring to the class itself, and that's necessary in order to actually set values inside of our class. We're using self.name to set the name variable here, and we're going to set it to whatever is passed in as an argument here to our init method. And we are doing the same for our age class. We can also add additional methods. So for instance, our sit method here, again we need to make sure that the self argument here is provided, or the parameter is added to our sit method. And here we want to say that when we call the sit method, we want to print out the name of the pet is now sitting. We can also add our other method, roll over, again needs to take self as an argument here, and then we can say that the dog here rolled over. In order to use it, we need to initialize an object from our class, and to do that we can do the following. We simply say dog, and then in parentheses we pass the name of the dog here, so basically whatever is defined inside of our init method. So here, aside from the self argument, which always needs to be provided, which we can ignore when we actually instantiate our class here, we provide name and the age inside of the init method. So those are the 2 arguments here that we pass to our dog class here in order to instantiate our object. So here we pass Willy as a name and then 6 as the age, and that is saved in this variable myDog. And of course we can go ahead and we can instantiate another object. We would do the same thing here. We write dog as the name of our class, and now we pass a different name and also a different age to it, and those values as well are stored in a variable in a different variable here. And now we can of course go ahead and access the information in our objects here that we defined, and specifically we want to access the attributes of our class. In order to do that, we are using what's called dot notation. That means we are referencing the name of the object, so for example my dog, followed by a dot, and then we reference the attribute. So for example, the name. We can use that in order to simply print out the name. We can do the same for the age. So here we can use mydog.age in order to return the age that we provided here. And of course we can take the same steps for the other object here for your dog and simply repeat that. In addition to referencing those attributes, we can also call methods. So here in order to do that, we would simply use a dot notation again and call, for example, .sit on our object here, and that will work as well. So if we run our code, we can see that first of all we are printing the name. So my dog's name is Willy, for instance, and my dog is 6 years old. But then we also call the method sit on it, and sit prints out the statement here. So the name is now sitting, so Willy is now sitting, and we're doing the same for the other dog saved in your dog with Lucy as a name and an age of 3. So this is how we can instantiate an object based on the class that we defined, and how we also can instantiate multiple objects just by assigning this to a separate variable, for example your dog, my dog, and of course we could create any number of additional objects. And it's important to understand that the class is kind of our blueprint, if you will, that we can use, and then we basically instantiate our class and create a new object, any number of objects based on the class that we defined previously. So let's take a look at the exercises. So in the first exercise here, restaurant, we should make a class called restaurant, and the init method for our restaurant class should store 2 attributes, a restaurant name and a cuisine type. And then we should create a method called describe restaurant that prints these 2 pieces of information, and a method called open restaurant that prints a message indicating that the restaurant is open. After defining that class, we should make an instance of it called restaurant from our class, and then print the 2 attributes individually and then call both methods. So let's do that. Initially we should create our class. So again, we are using the class keyword followed by the name of our class, so restaurant in this case. We add a colon after that, and of course we can also provide a docstring just to provide a little bit of documentation. Next we want to use our init method, and as specified we are going to accept the restaurant name and also the cuisine type. Now in order to properly assign those values, which we will get once we start creating an object from our class, we need to actually assign whatever we get back, so the restaurant name, to our restaurant name itself, and we should do the same for the cuisine type. And the init method of course will be called again when we actually call our class, so when we instantiate our class and assign it to an object. Next we want to define our describe restaurant method, which does not take any additional arguments except for the self attribute here, which is required, and then we're gonna print out the restaurant is called, the name of the restaurant, and what the cuisine type is. The second method that we're going to add is open restaurant, which is going to print out that our restaurant is open. And then of course we need to instantiate our restaurant, again passing in the values defined inside of our init method, so the restaurant name and the cuisine. And then we're going to print out what the restaurant name is and what the cuisine type is, so we are accessing the attributes using the dot notation here. And in addition to that, of course, we can call the methods again using the dot notation, so we're going to type out restaurant, which is the name of the object that we created by instantiating our class, followed by the actual method name. Now when we run our program here, we can see that it prints out exactly those values, so the name of the restaurant that we provided as well as the cuisine type. The next exercise asks us to build on top of the exercise we already wrote, and we should now start with our class and then create 3 different instances from the class and call describe restaurant for each instance. So if we head back to our file, we can see we have our class defined here with our init method, describe restaurant and open restaurant, and now we can go ahead and basically instantiate 3 different restaurants. So if we do that, we would simply again call restaurant, our class, and then provide the name and the cuisine type and save that back in a variable in our object that we're using. And we do that 3 times for different kinds of cuisines. So for example, French, Italian and Chinese, and we provide those values. And after that we can simply use each of those variables here, each of those objects, and use dot notation to call describe restaurant. And now when we run that, we can see that the name of the restaurant is printed out as well as the type of cuisine. The third exercise here is to create a class called user, and we should create two attributes called first name and last name, and then create several other attributes that are typically stored in a user profile. We should then create a method called describe user that prints a summary of the user's information, and another method called greet user that prints a personalized greeting to the user. And finally, we should create several instances representing different users and call both methods for each user. So let's do that. We again start out by creating our class by typing in class followed by the name of the class, and optionally of course with the docstring. Then we are using our init method. We are passing in self, which again is required, then the first name, the last name, and then optionally additional attribute. And of course we need to make sure that inside of our init method we actually assign those values that we get from the user from instantiating the objects, that we actually store that using the self keyword and the dot notation inside of our variables. Next we have our describe user method, which prints out what the user's name is and also the age of the user and the location. And then we have our second method here, greet user, that greets the user using their first name and their last name. Now once we define that class, we can then instantiate it, setting up the different objects. So here we can go ahead and we can call our user class, passing in the values, first name, last name, location, and age. And once we have done that, we can of course then use the dot notation on the object here on the variable and call describe user and greet user. We can do the same a second time here by creating an additional user object here with other values and calling the same methods on it. Now when we run that, we can see that precisely those values are actually printed out here to the terminal. So we saw how we can create new classes and how we can use them to represent many real-world situations. One important aspect to understand is how we can actually update and modify those attributes of an instance, and how we can write methods that update attributes in a specific way. So let's take a look at an example and let's create a car class with different attributes and methods. So initially, of course, we want to make sure that we specify and create the car class itself with a docstring here. We also need to provide the init method, and for our car we want to accept the make, the model, and the year of the car. That again will be set to the local variables here that are referenced using the dot notation using self. We also want to add a method getDescriptiveName that returns the year, the make, and the model of the car. Now once we have that in place, we want to instantiate our new car, passing in the make, the model, and the year. Then we can print out our object using getDescriptiveName to actually return the information. So if we run this now, we can see that we get back the year, make, and model of the car that we instantiated. So to make this class a little bit more interesting, let's add an attribute that changes over time. So we'll add an attribute that stores the car's overall mileage. And when an instance is created, attributes can be defined without being passed in as parameters. Those attributes can then be defined in the init method, where they are assigned a default value. So let's add a new attribute called odometer reading that always starts with a value of 0. And we can simply add that here to our init method, and that we always have the default value of 0. We don't have to actually provide it as a parameter here to our init method, because it will always be set without being influenced by any user input. We can then also add an additional method in order to actually read the value out. So here we have an additional method, read odometer, that actually prints out our current odometer reading and the amount of miles that we basically covered. Now in order to actually print this out, let's simply add an additional line here, and let's call our method here on our car that we defined. So now when we run our program, we can see that this car has currently 0 miles on it, because that's exactly the value that we defined here when we initialized our car. But not many cars, of course, are sold with exactly 0 miles on the odometer, so we need a way to change the value of this attribute. And we can change an attribute's value in 3 different ways. First, we can change the value directly through an instance. Second, we can set the value through a method. And third, we can increment the value or add a certain amount to it through a method. So let's take a look at each of those options in turn. The simplest way to modify the value of an attribute is to access the attribute directly through an instance. So in this case, we can simply set the value to a certain value directly. So here we can say we are referencing the attribute odometer reading that we have in here, and we directly set that to a certain value. So if we run our code again, we can now see that our car now has 23 miles on it, because that's exactly the value we specified here. So sometimes we want to access attributes directly like this, but other times maybe we want to write a method that updates the value for us. And that's the second option that we have. So in order to do that, let's add a method to our class that allows us to update the odometer reading, and we're going to pass a certain value to our method in order to actually make that kind of update. So here we have our additional method update odometer that takes the mileage in, and then we are checking if the mileage is greater than the odometer reading. In that case, we are going to basically set the mileage that we provide here to our odometer reading. If that's not the case, then we can print out that we can't roll back an odometer, because we always want to make sure that we actually provide a valid value here, that we don't reduce the number of miles we already covered. And then of course we need to actually call our method here, update odometer. We passing in the amount of miles that we want to update, and just to make sure that it's worked properly, we're then using read odometer. So as we run this, we are basically getting back that we have 23 miles on it, which is exactly what we specified. So the method update odometer that we are using allows us to update the value for our mileage here and set it to a certain amount. But in some cases we maybe don't want to set it to a certain amount, but just increment it, increase it by a certain number. And that of course is possible as well. In order to accomplish that, we would simply add another method to our code. So here we can say we add increment odometer, which takes in the amount of miles that we want to increment our reading by. And then instead of setting the miles directly as we did here inside of our update odometer reading, we are instead incrementing it. So here we are incrementing the amount of miles in our odometer reading by the specified amount. And now in order to use that, of course, we need to call our method. And as an example, we are defining a used car here. We're passing those values to it. And then we are, first of all, updating our odometer, setting it to a value, in this case of 23,500. We are reading our odometer, and then we are incrementing our odometer by another 100 miles and read that out again. So if we run our code, we can see that this car here has, first of all, the initial value, so 23,500 miles on it. But then once we call increment odometer, we're increasing that by another 100 miles, and that's printed out. Continue with the exercises. The first exercise here is numbers served. We should start with the program we wrote before. That was about the restaurant class, and we should add an additional attribute numbers served with a default value of 0. Then we should create an instance called restaurant from this class, print the number of customers the restaurant has served, and then change this value and print it again. We should also add a method called setNumberServed that lets us set the number of customers that have been served. We should call this method with a new number and print this value again. And then we should add a method called incrementNumberServed that lets us increment the number of customers who have been served. We should call this method with any number that we'd like, and that could represent how many customers were served in, for example, a day of the business. So let's switch over to Sublime and let's take a look at that. So initially, of course, we are starting out with the restaurant class that we already wrote before. Just as a reminder, we had an init method here that accepted the restaurant name and the cuisine type. We have the describe restaurant method that prints out the key information about the restaurant, so the name and the cuisine type. And we also have a second method here that states that the restaurant is open. Now in the next step we can add, first of all, an additional attribute to it. So that is the numbers served, which we set to 0. So when we create a new restaurant, the numbers served is automatically set to 0. In the second step, we can add an additional method, setNumberServed, which basically allows us to pass in the number of guests that have been served. And that is stored here back in our numbers served variable, and of course we need to use the self keyword with a dot notation in order to properly save that. Secondly, we're going to add another method, increment numbers served, which allows us to increment the number of users. We pass that in as we call the method, and we are increasing the number of customers served by the specified amount. Now, once we've made those updates to our class, we can then instantiate a restaurant and call these methods, or of course we can change the attribute directly using number served. So let's take a look at that. First of all, of course, we instantiate our restaurant here, passing in the name and the cuisine type. And we can of course initially just reference the number served directly by using the dot notation restaurant dot number served. So as we run our code, we can see a number served initially set to 0 because that's exactly what we initialized this value to be. Next, we can update the number served directly by updating the attribute using the dot notation. So in this case, we are directly referencing number served here and updating it to a value of 200. So as we run our code again, we can see number served is now updated to 200. As an alternative, of course, we can use our method set number served and directly use our method to update the number of guests. So in this case, we pass a value of 300 to it, and this is going to update our number of served customers to 300. And then of course we print that out again. So as we run our code, we can now see that after calling this method, we served a total of 300 customers. Additionally, we can use increment number served, which allows us to not directly modify the number of customers, but to increment it by a certain amount. So in our case here, we are updating it from the original value, so 300 in our case, and we increment that by another 100. So it should be a total of 400. So as we print this out, we can see we now have a total of 400 customers that we served. The second exercise, login attempts, is an update of the user class that we wrote previously. So we should write a method called increment login attempts that increments the value of login attempts by 1. We should write another method called reset login attempts that resets the value of login attempts to 0. And then we should make an instance of the user class and call increment login attempts several times. Let's print out then the value of login attempts to make sure it was incremented properly. And finally, we should call reset login attempts to reset the number of login attempts. And finally, we should print out the value to make sure it was reset to 0. So let's do that. If we think back, we created the user class before with the init method, describe user method, and the create user method. And now we want to expand that. So first of all, we want to add an additional attribute, login attempts, and set that to 0. So whenever we create a new user, that new user obviously never tried to log in, so it has an initial value of 0. Additionally, we add the method increment login attempts that simply updates the number of login attempts by 1. So we could use it, for example, in a web application whenever a user tries to log in unsuccessfully, for instance, then we want to increment the number by 1. Next, we add the reset login attempts method. So when we call that, we reset our login attempts to 0. We could use that in a web application, for example, in order to prevent a user to try to sign in again if that user signed in, let's say 5 times unsuccessfully, just in order to increase security. So let's use our methods that we just defined to call that on our user object. So initially, of course, we need to create a new object here by instantiating our class. We're passing in the required values, so first name, last name, location, and age, and we store that in our user object here. And next, we are then incrementing our login attempts by calling increment login attempts, which again increases that by a value of 1, and then we print out the number of login attempts. So as we run our code, we can see we have a total of 3 login attempts because we called our method here 3 times. Now, if the user then signs in successfully, of course we want to make sure to reset those login attempts. So next we would call reset login attempts on that user object, and then just to make sure that this worked properly, again print out the number of login attempts, which should now be reset to 0. So as we run that, we can see after the reset, indeed our login attempts have been reduced to 0. When one class inherits from another, that basically means that we can use all the attributes and methods defined in the original class, in the parent class, and we can use that in the child class, the new class we are creating. But then we can of course add additional attributes and additional methods to really customize and specialize the subclass. So when we are creating a new class based on the existing class, we quite often want to use the init method of the parent class. So this will initialize any attributes that were defined in the parent class's init method and makes them available in our child class. So let's take a look at an example, and let's say we want to extend our car class that we wrote before by creating an electric car class. So an electric car is really just a specific kind of car, so we can base our electric car class on the car class we wrote before, and then we only have to add the code that's specific to the electric car. So let's take a look at that. And here we can see we have our original car class with our init method, and of course with the different methods that we created inside of our car class. Now if we want to extend that and we want to create a separate electric car class, what we can do is we can create a subclass. So the way it works is as follows. Again, we use the class keyword and then the name of the subclass that we want to create. And importantly, we are going to add in parentheses the name of the parent class that we are inheriting from. So here we can see we pass in car, which of course is the name of the parent class. And now if we want to basically use the capabilities that were already defined in our parent class here, specifically what is passed to it using the init method, what we can do is we define an init method here with basically the same attributes, with the same parameters as in our parent class, in the car class. But now in order to basically pass that over, what we can do is we can use the super function or the super method, which basically means we are referring not to the current class here, to the electric car class, but instead we are referring to the parent class of the electric car class, which of course is the car class here. So by calling super and then using the dot notation to call init, we're basically calling the parent's init method here. So that basically allows us to use the same parameters as defined here in our parent class in our electric car subclass. Now after we created that, then of course we want to initialize an object from our electric car class. So similar to how we did that before, we are instantiating our car, but in this case of course the electric car class, and we pass the make, the model and the year to it. And then we can, as we can see here, even though we are instantiating a new object of our electric car class, and this electric car class by itself only has an init method defined inside of it, we can still go ahead and then call get descriptive name, because since electric car is a subclass of our car parent class, it has access to all the various methods that are defined in the parent class. So let's take a look if that works properly. And we can see, even though we are calling a get descriptive name on an instance of the electric car subclass that by itself doesn't have the method get descriptive name, we still get this output here, because again, we don't have to basically repeat ourselves here. We simply create a subclass of the car class and we have access to all the methods defined here. And of course we can later on add any specific methods or attributes that are unique to electric cars, which are not shared with our general car class. And this way we can really specialize and really focus on just including the relevant information, the relevant attributes and methods in the respective parent or subclass. So for our electric car, what differentiates our electric car from a regular car is that it has a battery. So that's an attribute that's only specific to our electric car subclass. So let's add that attribute. And all we are going to do is self.battery size, and we are going to set that to 75. That means we have a separate battery here that's specific to our subclass. Now in order to print out what the battery size is, we can add an additional method that's specific to our subclass. In this case, we are going to add describe battery that simply prints out how big of a battery we have. Now next we can of course call our class by calling describe battery on it, And if we run that, we get back that in this case here we have a 75 kilowatt hour battery. So there's no limit to how much we can add to specialize our electric car subclass. We could add as many attributes and methods as we need in order to properly model our subclass. We can also override any methods from the parent class that don't really fit with our subclass. So in order to do that, we define a method in the child class with the same name as the method that we want to override in the parent class. And then Python will disregard the parent class method and only pay attention to the method that we define in the child class. So let's say, for example, our class car had a method called fill gas tank. So this method obviously does not make sense for an electric car. So in that case, we can simply override it. So in that case, we would simply add it to our subclass here. Here we're adding our function or method fill gas tank inside of electric car, and when that's being called on an object that's an instance of the electric car class rather than the general car class, we're going to print out that this car doesn't need a gas tank. So when we are modeling something from the real world in code, we may find that we are adding more and more details to a class. So we may end up with a growing list of attributes and methods, and our file may become quite lengthy. And in such a situation, we may recognize that part of one class can be written as a separate class. So we can break our large class into smaller classes that can work together. So for example, if we want to continue adding additional attributes and methods to our electric car class, we may notice that certain attributes are specific to a car's battery. And instead of just adding those attributes and methods directly to the electric car subclass, which of course we could do, a better approach may be to create a separate class for our battery, for instance, to reflect those methods specific to it. So let's go ahead and let's create a new class battery that actually includes all the information, attributes and methods which are specific to a battery. So to do that, of course, we are just going to use the class keyword again, followed by the name of our class that we want to work with. And we are going to add an init method to it. In our case, we are going to add the battery size to it, and we are setting a default value of 75. We are also going to add a describe battery method to it that prints out the size of the battery that we want to use. And what we need to do then is, in order to use it inside of our electric car class, we are going to adjust self battery size, and instead of setting it to 75 as before, we are instead going to basically instantiate our battery class here so that our class is being used inside of the electric car class. So when we actually create a new instance of electric car, as part of the init method, we are going to instantiate an object out of the battery class here, which is assigned as an attribute to our init method of our electric car class. And that means all the attributes that are relevant to our battery here that are enclosed in this particular class will be available when we create a new instance of an electric car class. Now we need to make small adjustments to our method here. So instead of calling describe battery directly on our Tesla, we now need to reference our battery first, which again is now an attribute on our electric car class here. So we need to basically say we are calling battery on our instance of our electric car class, and then on battery, because it's inside of our battery class here, we're going to call describe battery. So if we run that, we still get the correct output, so that's working properly. So now that may seem like quite a bit of work to create a new class here for the battery, but that can really help to keep our code clean, and especially if we have maybe some other classes that also need the battery here to work with, then it makes a lot of sense to split that out. Let's create an additional method to our battery class here. Let's say we are going to use the method getRange, which basically returns what the range is of our battery. So if we have a battery size of 75, our range is going to be 260 miles, and if we have a larger battery with a size of 150, then our range is going to increase to 315 miles. And then we're going to print out what the actual range is for our electric car. Now let's call this class. So we're going to say my Tesla. Again, we need to use the dot notation here and call battery because that's included in our battery class, which again we reference directly from our electric car class here. And then we're going to call getRange. And now if we run that, we can see we have a range of 260 miles because we have a 75 kilowatt hours battery set to it by default. Let's continue with our exercises. The first exercise here asks us to model an ice cream stand as a specific kind of restaurant. We should build on top of the class we wrote before, and we should create a new class, ice cream stand, that inherits from the restaurant class we created before. We should add an attribute called flavors that stores a list of the ice cream flavors, and then we should write a method that displays these flavors. We should create an instance of ice cream stand and call this method. So this is the class restaurant we wrote before. We have the init method, describe restaurant method, and open restaurant method, and now we should create a new subclass that basically inherits from our restaurant class. So let's do that. We are going to create a new class called ice cream stand that inherits from our restaurant class. We are going to use the init method here, and inside of init we are calling super to reference the parent class or the super class, and then we are passing the restaurant name and the cuisine type. So the same attributes we have up here in our parent class as parameters here basically to our init method. In addition, we are going to use the flavor that is specific to our ice cream stand here, so we add that as an additional attribute. And now we can add our second method here, the display flavor method, that prints out what the flavors are, and in our case here, our flavors are basically passed in as a list, so we are iterating over each of the individual flavors, each of the values in our list, and print out that flavor. Now in order to use that, we need of course to go ahead and instantiate our ice cream stand and pass the various attributes to it. So here the name of the restaurant or the ice cream stand and the cuisine type, so it's ice cream, and then as a third argument here our list of flavors. Now once we instantiated our ice cream, we can go ahead and call display flavor, so our method here, in order to print out the various flavors, so chocolate and banana in our case. Let's go ahead and let's run that, and we can see that the flavors are printed out, so all of them are being displayed. And we accomplish that by using ice cream stand as a child method to our restaurant method. So we inherit the main attributes from restaurant and we extend that class with additional attributes such as flavors here in our case, and we are also adding an additional method that's specific to our subclass, to our class ice cream stand. The next exercise, admin, asks us to create a separate subclass of an existing class, so we should write a class called admin that inherits from the user class that we wrote before. We should add an attribute privileges that stores a list of strings such as can add post or can delete post, and then we should write a method called show privileges that lists the administrator's set of privileges. Finally, we should create an instance of admin and call our method. So let's do that. Here's the user class that we wrote before with our init method, describe user and greet user method, and now we want to create a specific kind of user, an admin user, so a new class that inherits from our user class here. So of course we can write the admin class name, and in parentheses of course we provide the name of the parent class, so of user. That means we inherit all the attributes and the methods from the user class to our admin class. Additionally, we need to provide an init method, and in our case here we of course pass the same values to it that are part of our user class, so first name, last name, location and age. But additionally we are also going to pass privileges to our subclass here. Next we are going to add an additional method, show privileges, that prints out the privileges, and those are passed in as a list. So in our case we can iterate over the various entries in our list. So for privilege in privileges here, we are going to print out the privileges assigned to that admin. And in order to work with our admin class, we of course need to instantiate that by calling admin and passing in all the various parameters here that are required as arguments to our class. And in addition to the arguments that we defined before, we are going to add our privileges, of course, that are passed in as a list. And then we are going to call show privileges in order to actually print that out. Now when we run our code here, we can see that we see the privileges, so can add post, can delete post, and can ban users are the different privileges assigned or associated with our admin class. Those are specific to the admin class, they don't apply to other kinds of users, and therefore we separated that out into our child class here. The next exercise, privileges, builds on top of what we just did before. So now we should write a separate privileges class. And the class should have one attribute, privileges, that stores a list of strings as described in the previous exercise. And then we should move the show privileges method to this class and create a privileges instance as an attribute of the admin class. We should then create a new instance of an admin and use our method to show the privileges. So let's do that. If we take a look at the class we wrote before, the admin class, what we now want to do is we want to move the method we defined in there before and move that to a separate class, similar to what we did before when we worked with the electric car class and we created a separate battery class. So in order to do that, we can create our class privileges here as a separate class. And of course, we need to provide an init method here, and we want to pass privileges to our privileges class. So therefore, we define that as a parameter for our init method here. And we assign that to self.privileges. And now we can go ahead and we can add the show privileges method that we previously used with the admin class here. We can assign that to that separate class here. Now in order to use that, of course, we need to add self privileges to our admin class, and then we need to instantiate basically an instance of privileges. So that's what we adjust here. So we say we pass privileges to our privileges class and then assign that to self.privileges. The last step we need to take here is once we instantiated our admin user, we can't directly call show privileges on our admin object. Instead, we need to reference privileges, which again is now an attribute of our admin class here. And this attribute here contains an instance of the privileges class that we defined here. So by taking that extra step, going to the privileges attribute, we can now call show privileges. And if we run our code, we basically get the same output as before, but now we split it up a little bit more and basically moved the show privileges method out inside of a separate class to have our code a little bit shorter and a little bit more succinct. So the final exercise here, battery upgrade, asks us to build on top of the electric car class that we wrote before, and we should add a new method to the battery class called upgrade battery. And this method should check the battery size and sets the capacity to 100 if it isn't already. We should then create an electric car with the default battery size, call getRange once, and then we should call getRange a second time after upgrading our battery. And that should then increase our car's range. So let's take a look at the code we had before. So here we have our three classes, car as a parent class, then electric car as a subclass that inherits from the car class, and of course a separate battery class that contains all the attributes and methods specific to our battery. Now let's go ahead and let's actually add our additional method here. So upgrade battery is a new method that we assign to our battery class, and that's going to check what the battery size is, and if the battery size is not equal to 100, then we are going to upgrade that to 150. Next, in order to actually work with that, we need to instantiate our electric car class and pass the required attributes to it, the different arguments, so the make, the model and the year, which are the values here. And then as a next step, we should call getRange on it, which is the method that we defined up here inside of battery. And so if we call that at this point, we will see that we have a range of 260 miles because we have a default battery size of 75. But in the next step now, we should check that we call upgrade battery, and if our battery does not have a capacity of 100, we should upgrade it, so it's a larger battery. So that's basically what we are doing here. And after that, let's call getRange again to see if that upgraded the range of our electric car. And let's just have a quick look here what upgrade battery does in detail. So since our battery size is not equal to 100, we have by default a battery size of 75. We are upgrading it to the larger battery size to 150. And if we call getRange again, we will see that if the battery size is equal to 150, we should increase the range from 260 miles to 315 miles. So let's run our program, and we can see that indeed by calling upgrade battery and then getRange again, we increased the mileage here, the range, from 260 miles to 315 miles. So our method here is working properly. As we add more and more functionality to our classes, our files can get really long and it may be difficult to keep track of what's actually going on, especially if you're using inheritance as well. So in order to keep with the overall philosophy of Python, we want to keep our files as uncluttered as possible. In order to achieve that, we can actually move our classes into separate modules, and then we can import those modules when we need them. So we can create a module that contains just the car class. If we want to instantiate an object from our car class, we can then simply import that car class from our module. So let's take a look at that. If we think back, we have our car class here that is simply the class definition of our car with the init method and of course with the various methods. In order to basically import that and use that in a separate file, what we can do is we can create a new Python file here, and then of course we need to be able to import our car class here into the new file. And the way it works is our car.py file is not just a file, but it also works as a module. So all we need to do is to basically say we want to import from our car module, so from our car.py file, we want to import our car class. And once we've done that, we can simply go ahead and instantiate a new object, for example called myNewCar, from our car class by passing the required arguments to it. So these are the ones defined inside of the init method here, just as we did before, but now we moved that to a separate file. Then of course we can also just call the methods on our new car object here, for example getDescriptiveName, and we can also update its attributes just as we did before. So that is possible to, for example, update the odometer reading, and then we can also go ahead and call the methods here as well. Now if we run that, it works just as before. The only thing we basically changed is we added this import statement here on top, and that allows us to keep our code that we're writing and our file size much shorter, because we can have separate files for separate classes and then just import them as we need them. Store as many classes as we want in a single module, and then simply reference any of those classes in a separate file. So for instance, inside of our car.py class, we will want to not only include the car class itself, but for example also the battery class and our electric car class that's inheriting from the car class itself. Now if we want to, for example, to reference only the electric car class in a separate file, we can do that of course. In that case we would go ahead and say we want to import from our car module only the electric car class, and then we can go ahead and we can instantiate a new object from our electric car class, call any methods on it, for example getDescriptiveName here, or for example describe battery and getRange. And if we execute that, of course we see the same output as we would if we did that directly inside of the car.py class, so we can use that approach to import classes from a module that can include multiple classes. We can import as many classes as we want from a module. So for instance, if we want to, let's say, import not just a single class, but for example the car class and the electric car class, we can do that. In that case we just say from our car module we want to import both the car class and the electric car class, and then of course we can go ahead and instantiate, for example, a regular car here and then call any methods on that. And of course we can also instantiate a new electric car and call a method on that. And of course we get the correct output. We can also import an entire module and then access the classes that we need using dot notation. So this approach is simple and results in code that is easy to read. And as an example, let's take a look at how we can do that using our car class that we saw before. So if we are importing our car module And inside of our car module, we have multiple different classes, such as the car class, but also the battery class and the electric car class. We can of course go ahead and then simply reference any of those classes inside of our module using the dot notation, and then for example either create a regular car as we see here or an electric car. Those different classes can simply be referenced using the dot notation, and if we run our code we see we still get the same output back. We could even go one step further and import all classes from a module. So we could say we want to import from a certain module name, for example from the car module, everything that's inside of it using the asterisk symbol here. But this is generally not recommended for two different reasons. First of all, it's helpful to be able to read the import statement at the top of a file just to see what we are actually importing, which kind of classes. And second, this could also lead to confusion with names in the file. So if we accidentally import a class with the same name as something else in our program file, we can run into errors. So therefore we should generally not use this approach, but instead simply import the separate classes themselves or the entire module, and then referencing the classes inside of that module using the dot notation. As we saw before, we can also use aliases to use custom names when we import some modules or for example classes to more easily reference the imported classes or modules. So as an example, if we want to import the electric car class from our electric car module and we want to give it a custom name, we can simply say we are going to import that specific class from our module, but then we use the S keyword to actually assign an alias. So in our case here we're using the alias EC, and then we can simply use that instead of always typing out electric car. So as we saw, we have multiple different approaches of how we can structure our workflow. We can either import individual classes directly, we can import multiple classes, or we can import entire modules. And on top of that, we also have the option to use aliases to reference and assign different names to the different modules and classes we are working with. Let's continue with our exercises, and in the first exercise here we should use our restaurant class that we created before and store it in a module. And from a separate file we can then import our restaurant module, we can create a restaurant instance and call one of the restaurant methods to show that the import statement is working properly. So let's do that. We have our restaurant class here that includes our class definition, the init method, and then also two additional methods that we defined. And in order to use that in a separate file, all we need to do is to basically say we want to import the restaurant class here from our restaurant module, so from this file name here, and then we can go ahead and instantiate the separate restaurants here, and of course call our methods, so for example describe restaurant. And if we run this works just as before, so it doesn't really matter if we do that in a single file or if we separated it out in two separate files and then simply use the import statement in order to import the module and the class to be used in this separate file. The next exercise here, imported admin, asks us to start with the work that we created before in exercise 9.8, and we should store the classes user, privileges and admin in one module, so in one file, and then we should create a separate file and make an admin instance and call show privileges to show that everything is working correctly. So if we take a look at the file from before, privileges.py includes our class user, our privileges class, and also our admin class. Now in order to use that in a separate file, we can first of all start out by importing the admin class here from our privileges file, and then of course we can go ahead and we can instantiate a new object, creating a new admin instance here, and then we simply call show privileges, and we can see that still works properly. So for our third exercise here, multiple modules, we should store the user class in one module and store the privileges and admin classes in a separate module. And then in a new file we can create an admin instance and call show privileges to show that everything is still working correctly. So we have our two separate modules here, and all we need to do is to say we want to import from privileges the privileges class, and we repeat the same for the admin class that is located inside of our admin.py file or module. Then we can simply instantiate our admin object here and then call show privileges and that still works properly. Already a number of modules automatically included with every Python installation, and those kind of modules are contained inside of the Python standard library. So for many common operations, it can be very useful just to use these standard modules that are provided, for example, when we want to work with random numbers. Let's take a quick look at an example. So if we open our terminal, we can, for instance, say that we want to import the randint method from the random module here, and once we have done that, we can go ahead and, for example, generate a random number between 1 and 6 by using our randint method, and that's going to give us back a random number in that specific range. And in a similar way, we can use other methods from the random module, for example choice, that allow us to select a random value from a list, for example, or from a tuple. In addition to that, we can also download modules from external sources, so we can really build on top of what already has been created by other programmers. Let's continue with some exercises. The first exercise, dice here, asks us to create a class die with one attribute called size, which has a default value of 6. And then we should write a method called rollDie that prints a random number between 1 and the number of sides that the die has. And then we should create a 6-sided die and roll it 10 times. So let's go ahead. Let's import the randint method from the random module, and then we can go ahead and define our class die. Of course, we need an init method. Here we can provide the number of sides with a default value of 6. And of course, we're going to have a separate method rollDie that prints out the die that we actually rolled. In order to use that, we need, of course, to instantiate a new die object from our die class, and then we can simply say that for basically the values in from 0 to 10, so 10 times, we want to roll our die. If we run that, we can see we get 10 outputs here, and these are the numbers that we are rolling. And now if we want to change that, if we want to have a 20-side die, for example, if we want to roll that 10 times, we can simply run that again, and now we see we have 10 new values, but this time in the range of 1 to 20. So the second exercise here, lottery, is focused on making a list of tuple containing a series of 10 numbers and 5 letters. We should randomly select 4 numbers or letters from the list and print a message saying that any ticket matching these 4 numbers or letters is going to win a prize. So let's start out by importing the choice method from the random module here. Then we have our list of values here, and all we're going to do is we are going to basically loop over 4 entries, or basically repeat it 4 times, and then use the choice method here to pick a random value from our values list. So as we do that, we get a random selection back. Third exercise here, lottery analysis, asks us to create a list or tuple called myTicket, and then we should write a loop that keeps pulling numbers until our ticket wins. And finally, we should print a message reporting how many times the loop had to run to give us the winning ticket. So again, we're going to need the choice method here from the random module, so we are importing that. We also have our list of values, and we are randomly selecting the winning ticket here using the choice method. And then we are simply going to loop over the entire length of the list here and going to print out the choice that we selected, and if the selected value is equal to our ticket, then we are going to print out how long it took us actually to get to the winning ticket. And finally, of course, we want to break out because we don't want to continue the execution of our for loop. Of course, we could have also used a different approach, for example using a while loop instead of a for loop, but this should work perfectly fine. So if we run our code here, we see in our case here we start with 8, E, C, and so on and so forth until we get to the winning ticket, which is 8. So it took us 8 iterations in this case. If we run this again, now it took us even longer, 13 iterations. But of course it may also take us fewer iterations, for example here 6 iterations, to get to the winning ticket. And then the final exercise is about exploring a little bit more about the Python standard library. So there's a website called Python Module of the Week, and we can navigate to it and just take a look at the table of contents and take a closer look at the modules that are interesting to us. We learned how to create our own classes in Python, how to use the init method to instantiate a new object from a class, and also how to use inheritance. If you have any questions about that, feel free to add them to the comments down below. In the next video, we are going to cover files and exceptions. So see you guys in the next video.